Hi, my name is Jan Simon. I'm Head of Technology at commercetools. Today I would like to talk about bringing a public GraphQL API from beta to production ready at scale. A bit of context about commercetools. We are an e-commerce platform, API first. We also provide a web application so that merchants can manage their products, their discount, and so on. Customers consume our API from their servers to support their web or mobile applications. They also consume our API directly for mobile application or single-page application. We are cloud native and we integrate with cloud functions and cloud queues. How does GraphQL fit into that picture? So this is our story. How we introduced GraphQL at commercetools from 2015 to 2021. Back in time, 2015, Facebook published the first draft of the GraphQL specification. A colleague of mine, Oleg, started working on the Scala implementation. And in October, it will push the first GraphQL endpoint at commercetools. This endpoint was experimental so that we could learn when using that how it can support our e-commerce use cases. Between 2015 and 2018, we continued working on the GraphQL endpoint, adding more and more features. From 2018, we could observe that customers were very much interested in our GraphQL support and started using that. From 2018 until now, the GraphQL traffic has grew up ever since. We are now in 2021 and we provide a public GraphQL API that we support and that customers are using on production. We also provide some tools that external developers can use. We also advocate and inform customers about how they can use GraphQL. So what happened in between? As you could see, the traffic of the GraphQL endpoint has increased and we had to scale up. I will look at that from 3 different angles. From the operation perspective, from the development side, and from the performances. So first, we had to scale up operation. I will start with an example. You can see 2 GraphQL queries. On the left, we fetch the ID on the version of different products. On the right, we fetch the ID, the version of different products, and also the name of the product type. To execute the second query, we have to fetch the product types of different products. So you have the feeling that we need more resources to run the query on the right than the query on the left. A malicious user could use that to send us queries that are very complex to execute. Those complex queries that are a risk for our production server. So we had to protect ourselves against that. So to protect ourselves against malicious queries, there are different options, and this is the one that we are using. When we receive a query, we analyze the query, compare that to the schema, and we know how we will resolve each field. And based on that, we can estimate the complexity of the query even before the query is executed. Queries that are too complex are blocked. So this is one strategy. There are others, and I put some links if you want to inform yourself about all possibilities that you have to protect yourself against malicious queries. We traditionally offer a REST API. And when you look at live HTTP traffic of REST API, you can fetch a lot of information. You know if it's a read or write, on which resources, if the query was successful or not. And then we had to introduce a GraphQL API. You might know that GraphQL is transport agnostic. So it's possible, for example, to propose GraphQL in XML format on top of email. What we are using is the setup that I think is the mostly used in the world. Is we propose GraphQL on top of HTTP in JSON. But now, if we look at the live traffic, if we use at the HTTP loads, we only see posts on the GraphQL endpoint. And this returns a 200. Compared to the information we had by looking at traffic of REST APIs, we are losing a lot of information. So to avoid that, we have added additional information in the loads entries. For example, if the operation is a query or a mutation, on which field? I've introduced you to the query complexity, and we also exposed that in the HTTP logs. And we know if there were some errors or not when executing the query. So with those additional information, now we can have a look at live traffic and know what is going on. We also know what is going on because we also have introduced a lot of metrics. General metrics about, for example, the number of queries that we have, the numbers of errors, where do we spend execution time, and also metrics that are specialized about slow queries that take time to complete. With those metrics, we have a global overview on what is going on our live servers. And to better know about queries that are slow, we have also added slow logs, where we know the query and all additional information we need to understand the query. If you use such an approach, just be careful not to load sensitive data like user passwords. So in the past years, we have scaled up operations. First, to protect ourselves against malicious queries. Then we have added more information on HTTP loads, with metrics, with slow loads. And all these informations give us confidence in operating GraphQL API live at scale. Now let's have a look at the development side. So to speed up the development of the GraphQL API, we have started using that API ourselves. So the Merchant Center, the demo shop, they all are using the GraphQL API. That means for us, internally, we have much shorter feedback loops. Developers can talk to other developers, making suggestions how to improve the API design. So we work on the API design of the GraphQL, and we have added more and more convention. One of these conventions is how we expose localized fields. For example, the name of the category is localized, and we can ask for one translation, like in English here, or we can ask for all possible translation. So this convention came from our experience working with our GraphQL API. But conventions are good if they are used everywhere. So what we did is we have added internal validations based on our GraphQL schema. And if a developer forgets, for example, about one of these conventions, the compilation will fail. and we can see an error showing which validation does not pass and how to fix that. To speed up development of GraphQL, we could also automate some part of the schema. I will explain. Our REST API is following a CQAS architecture. It means we have different models for queries and mutation, exactly as what we know in the GraphQL world. We could use that model and generate part of the GraphQL schema. So this sped up a lot the development of the GraphQL schema. A drawback when we generate things is we could generate too much and expose APIs that we don't want to expose. So to avoid that, we are using schema introspection to test what is exposed. Example of such a test is on the right when we check which update actions are available to update one shipping method. If we expose too much, the test will fail. The GraphQL schema is also very useful for other automation. When we are working on a new feature, the GraphQL schema that we are using in development might be different from the one that we have on production. In our pipeline, we check those differences. First, we check if there are some breaking changes. If there are some breaking changes, the bit failed. So to make sure that we don't break existing customers' implementation that are relying on our GraphQL schema. And then based on these differences, we generate Markdown files that are being used for our public documentation. Like for example, the release notes, all this part was automatically created from differences from GraphQL schema. Having this automation also helps having more consistent API release notes. When we started working on GraphQL, we used some convention that changed with the time. So we also had to change our schema. We did that without breaking customers' implementation by using deprecation. So in GraphQL, it's possible to deprecate one field. And we also document how to fix the deprecation. We have metrics about deprecated fields to know which deprecated fields are being used and by whom. Then we can approach customers to help them fixing their deprecation. Those metrics are also very useful because we can know when a deprecated field is not being used anymore. So we check, for example, in the last 3 months, this deprecated field was not used anymore by no one, so we can safely delete this field. This helps us evolve the schema step by step. So this is how we scaled up our API development. First of all, having faster feedback loops, developers talking to developers, having better suggestion. Then we scale up the development with automation by generating GraphQL from our REST models, by validating automatically the schema for consistency, and by automating checking for breaking changes and generating public documentation. We have used deprecations to evolve, and now our GraphQL coverage is complete. We have the same feature in GraphQL and the REST API. So that we have more and more traffic on the GraphQL API. So we have to make sure that we are performant. How do we do that? First of all, a GraphQL query can be expensive to execute. And sometimes external developers do not know that they are using maybe a field that is expensive to execute. So what do? Is we give external developers tools to have better knowledge about that. We expose the query complexity as HTTP header. So if the complexity is high, it's a sign for developers to check what is complex in the query and what I can simplify. And also we provide profiling. Profiling is when you send us a GraphQL request, and in the response, we also attach the times that has been used to complete each field. So based on that information, it's possible to know which fields are expensive to execute. In REST API world, when we fetch information, we sometimes receive a payload with information that we don't need. In GraphQL, it's possible to select only the fields that we need. By doing so, the payload that is being sent from the server to clients can already be smaller just by using GraphQL. We wanted to check how much impact does it have to minimize this payload. And this is an example with an Apple Watch application. On the left, using REST API, on the right, using GraphQL, just to fetch the fields that are necessary. What you can observe here is by just using GraphQL, just by minimizing the payload, the application is much more responsive. So minimizing the payload is useful for applications running on running with little CPU, for example. It's also useful for servers. We have a lot of customers are using server-to-server communication, and one of them shared with us some internal metrics that when they switch from REST to GraphQL, they could observe much better performance, just because the servers have much less data to handle. But when we use GraphQL, it's also possible to optimize the part between the servers and the databases. Because the server knows which fields the clients would like to have, it's possible to optimize the database query. I made an experiment about that, and I will show you the results. So this is fetching products with the REST API and fetching products with GraphQL API. So you can see that just by optimizing the payload between client and server, we can already observe a performance improvement. And then by using the information from the GraphQL query to optimize the database request, you can see here that we could also observe a performance improvements. So at the end, with GraphQL, it's possible to improve the performance for the whole flow from the clients to the database. So this is something that we are using to optimize our performance. And we have a lot of live traffic, and we inspect our servers on production to check where the time is being spent. For example, by using flame graphs, we can know which part of the code is quite slow. We can write benchmark about that and trying to improve the code. So with that approach, we could improve the code that we are using and also the code being used in the Scala library, giving back to the community. So this is how we scale up performances. First, by giving tools for external users so that they can optimize their query. Then internally, we can optimize the database that we send, the queries that we send to database based on the GraphQL query. And continuously, we inspect our live servers and we check which parts we can optimize. So to evolve a public GraphQL API from experimental in 2015 to production ready right now, we needed investments in a lot of different areas. We have invested in automation to have faster GraphQL development, to quickly check for breaking changes, to automate documentation. We have invested in operation to have a lot of information live about what is going on production, to be able to quickly resolve any issues. And this is a continuous improvement. Based on issues, based on what we can observe, we check what we can make better. Also, it's a process that involves everyone. We spoke about front-end and back-end developers. It also involves product manager. So we are API first, so product manager are involved in design of our API. But it also involved sales, marketing, support to explain GraphQL to customers and to support them using GraphQL on production. So now we have a GraphQL API public that we support, and we are ready to have even more GraphQL traffic. That's all I have. Thank you for your attention.